3%. That's the percentage of large drugs that have been approved or are in development in the animal health world compared to 15% in human health. So this is obviously a big gap, particularly good opportunity for biotech companies that are developing new antibodies or might have already a target. They want to revalidate it. And so today we talk about comparative biology, and we have a little bit of a look at the differences between the human and the canine system. So we start with the similarities. The main similarities: cell types, cell function, the function of the MHCs, class 1 and class 2, the way that antibodies are developed, and the percentage of the different white blood cells in the blood. That is already really good. This is also why this is one of the models that are most commonly used. So in most of the cases, we just have to re-engineer and canonize the human antibodies or the murine antibodies, whatever you're doing. But if you look at the differences, it's worthwhile to have a look at it. So first of all, markers. If you look at cell surface markers, most of the time we use CD3 in humans to mark pan-T cells. And in the case of dogs, we have CD3 and CD5, and these are pretty much in the same percentages. And then in terms of the function, in general, T cells in dogs, they produce much less interferon gamma, but the macrophages and the whole innate immune system in general is much more sensitive to it. So they will respond at lower doses, upregulate MHC2 production and increase production of TNF alpha at lower doses. This is obviously much more intuitive because the innate immune system is much more developed in dogs, much more also prone to infections and different kind of parasites. But this also means that some tumor types that are not really common in humans, they are particularly common in dogs. For example, mast cell tumors, especially in the skin. And in dogs, they make up to 21% of the skin tumors, so quite frequent as these tumor types. And then, as the focus of most of developers is antibodies, we want to focus on MHCs, the structure, the differences, the distribution. So we have MHC type 1, and those will be the one exposing epitopes to CD8 T killer cells that will look for infection, viral infections mainly, or parasitic infections. And we have HLA-A, B, and C in humans, with HLA-A02 probably being the most common in many populations. And in humans, we have in general thousands of different allele combinations, and they are located on chromosome 6. In dogs, for the MHC type 1, we have DLA, and DLA88 is the main one, with additional loci like DLA12 and 64 being also important, with much less polymorphic comparing to humans, mainly because of breeding practices through the centuries and millennia. Then if you go to the MHC type 2, these are the ones that are exposing epitopes to the CD4 T helper cells. Then we have HLA DQ and DP in humans, also on chromosome 6. And if you go on the canine side, we have DLA DRB1, DQA1, and DQB1 as the primary class 2 genes located on chromosome 12, while the DLA 88, 12, and 64 from the MHC1, they are split between chromosome 12 and 35. So these are the main differences between them. If you find this interesting, please leave me a comment. If you want, I prepared a short infographic. So if you comment comparison here, I will send you a DM with a short infographic for a summary. Thank you very much. Have a great day.